kinetics are basically what is the drug doing in the body. So it's absorption, distribution, metabolism, excretion. It's how the body handles it. What does it do with it? How does the drug move in the body? Pharmacodynamics are once that drug is there, what receptors is that? What's the potency? What's the efficacy? What does it do? Right? So movement of the drug in the body, interaction of the drug in the body. Volume of distribution is kind of this vague concept, but basically, theoretically, if that drug were to be totally absorbed, how much volume would we need to contain it? So mentally, the way to think about that is how much of this drug is actually free, unbound, in the plasma doing stuff. So if we have a really high volume distribution, that means that drug is pretty much anywhere other than plasma. So you need a really high volume to contain all that drug. So that means it's in fat and bone and organs, but it's not just floating around in your plasma. And in general, if a drug isn't free and unbound in your plasma, it's not doing anything. So that means that logistically, this drug isn't super potent. Don't directly correlate that, but just kind of think about it in your mind. Low volume of distribution means that these are things that are just cruising in your blood because they're either bound to plasma protein or they can't be bound to anything. So in general, a low volume of distribution means that there's a lot of it in the blood. Geiger loves the 4 half-life rule. What's the 4 half-life rule? 4 half-life steady state. So people ask you questions that sound super complicated because they'll say this patient has X, Y, Z going on, and they're given a loading dose of this and maintenance dose of that, and half-life of this drug is 6 hours. But then the other question is, how long until steady state of that drug? Well, it's 6 times 4, and you got it. So read between the lines on these questions, and what he's actually asking is how long to steady state, 4 half-lives. That's all. It's made way more complicated than it should be. For calculating half-life, if for some reason he was mean and didn't just tell you, 0.7 times the volume of distribution over the clearance. He would have to give you both of those things, but know that equation. Any equations he's given you, just know them. He will probably ask you for it at some point. Clearance in general is always just how fast you're getting rid of it versus how much is left in the plasma. That's your clearance rate. Depending on the order of your metabolism, 0 versus first order, you might have a changing rate of clearance. So just bear that in mind. And then he might give you the calculation for a loading dose. The big thing to remember is, in general, you always want to be a little gentle with your loading dose. You don't want to shock someone with toxicity the first go around. The big things that are going to affect whether or not you're changing your loading dose or your maintenance dose are going to be what is the integrity of their liver and what is the integrity of their kidneys. If either one of those 2 things is impaired, or for some reason they're a faster metabolizer, that will change what you're affecting. So for example, if they have cirrhosis and they can't metabolize it as well, maybe after your loading dose, give them a little bit lower maintenance dosing, because that means they're not metabolizing quickly. They're going to keep having a high level of this in their bloodstream. Versus if you know they have the genetic subtype that needs to metabolize quickly, you give them their loading dose, but then maybe up the maintenance dose a little bit, because they're going to be flushing out the system. But in general, your loading dose doesn't really change, because that's what's initially getting them to baseline. It doesn't have as much to do with how fast they metabolize. Questions? Yeah.
What's the formula for loading dose?
So it's basically your target plasma concentration is your C sub D, volume of distribution, and F is your bioavailability. Yeah.
What does it say after kidneys or volume of distribution?
Kidney disease. So yeah, liver and kidney disease are the 2 things that have a really profound effect on blood pressure. Is everybody cool with the idea of, yeah,
Is he going to expect us to know normal lab values for fasting periods? So,
you guys haven't done anything about creatinine and what that means yet, and nitrogen metabolism? Usually the only people that test for tables are O&M, and it's because of me. Yeah.
Stupid
You
idiots.
couldn't test myself. Okay, everybody cool with first order, 0 order metabolism? So these are the big ones to know for 0 order. The way I remember it is you got ethanol, you have to pee, 0 order. And so the big thing is just knowing that those enzymes that do this metabolism of those drugs can be saturated. You can hit a point where there's like, can't do anymore, so it's going to constantly pay out a fixed chunk, not a fixed proportion. So alcohol you clear 1 drink per hour. It doesn't matter if you've had 10 drinks or 1 drink, you're still going to clear 1 drink per hour. Versus pretty much every other drug except for those 3 is going to be a proportional one. They're going to take out 80%, 80%, 80%, because those enzymes don't saturate. Does that all make sense?
What's that first one on zero order?
Phenytoin is an anti-seizure medication. Do you guys want to know that yet? Okay. How to get things eliminated in the urine? So Dr. Geyer loves this question. Someone has overdosed on methamphetamine, and he will tell you PKA, and PKA will tell you it is a weak base. How do you increase their excretion? Make it acidic. Which, in the case of methamphetamine, you give them ammonium chloride, or vice versa. If it's a weak acid, you want to make it basic, give them a bicarb. All you're trying to do is trap that drug in a state that it doesn't normally want to be in, so that you can excrete it. Right? Because in general, things that are neutrally charged are way easier to get rid of than charged particles. So that's the idea. A weak acid naturally wants to be.
I thought charging gets rid of things.
It's hard to go across membranes. Remember, charged molecules don't like to go across membranes. I mean. They like to be wild. Just memorize.
So if it's already in excretion, you
Like,
charge it
don't
so that it
overthink
can't come
because
back,
it's
reabsorb.
metabolism,
Yeah.
all that. No, in general, the charged molecules don't like cross membranes. They'll ask you that. Miller in particular will ask you that in that spectrum of like urea versus oxygen versus ions. So keep that in your mind. This stuff gets more complicated.
But you're saying for weak acid, make it basic, which is going to make it have a charge.
No. You add pH where you add
It's about the portion. Remember the
HA,
Oh, yeah.
basic is going to be A1.
You're basically trying to change the concentration of one to the other to make it run into pH. Like if you suddenly have a ton of base in urine, that weak acid is going to try to go to the base to help neutralize. It's playing off of your body's desire to conquer things. So just err on the side of keeping it simple. It's more complicated than just that. But until you guys do acid-base stuff, run with it. Okay. Phase 1, phase 2. You guys covered this in the screen?
Yes.
Okay. Phase 1, phase 2. It sounds really complicated because there's CYP, 3A4, and I-7-8, and all that stuff. Just know it's cytochrome P450. It's this family of enzymes. Its job is drug metabolism. They all hang out in the liver. They're all in these liver hepatocytes that say, oh, there's a drug here. I should do something with it. The majority of what they do is reduction oxidation reactions. In general, they want things to be a little bit more polar, especially lipophilic molecules. They want them a little bit more polar so that they can go out into the bloodstream. Why do we want them in the blood? So that we can pee it out. So lipophilic drugs tend to just build up in your body's fat stores, and so they can stick around for a while. So as part of what these enzymes are trying to do is not have you build up this resting store of drugs in your system. The difference between phase 1 and phase 2. Phase 2, so this is usually changing the drug itself. Phase 2 is tacking something onto it, be it sulfur or phosphate, whatever kind of big, clunky molecule you want to add on. But it puts on something usually pretty polar. So phase 1 makes it a little bit polar. It kind of wants to go back into the bloodstream. This is your method of saying this drug is now inactive and ready to get out the door. Right? That's really the only big difference between the two.
Does phase 1 tend to be more toxic in general? Because you said it was for acetaminophen.
No, not in general.
So just for acetaminophen is
There
what's
are exceptions
bad?
to the rules about metabolism. Acetaminophen tends to have toxic metabolites. Not all drugs do. Any other questions? Yeah.
So it goes from phase 1 to phase 2. Can you excrete just after phase 1?
And it doesn't always go in that order.
Yeah.
Phase 2 can be first.
Yeah, these are just two different methods of getting things into the blood so that you can pee it out.
Okay.
I think those two are larger. Two might not touch, yes.
it's a Benson something carb rejection.
Barb takes pen.
Upregulate.
Yeah,
The
because
one,
it's-
the only downregulator that he shows was what, like grapefruit? Yeah, should we know more than that?
So he might give you a case saying like, you have a patient on this medication and they start showing significant toxicities from it, while all of a sudden they were taking liver juice.
Are the only inhibitor of the now?
Yeah, I think you do have to know all the other.
Like,
inhibitors
speak for a moment.
honestly.
Yeah, I asked him specifically after class, like how many of the drugs he wants to know, and he said definitely the inhibitors and what else was that?
Which inhibitors did he give you?
Inhibitors?
Suicide.
The antiviral, thrombolytic.
But he
There's
specifically
a
said great.
permanent, reversible, and permanent.
Wow.
Oh.
It's like this, you
I mean, yeah, don't get super bogged down in the inhibitors because it's kind of minutia and it tends to be broad classes like antivirals, some antibiotics, and it's not that specific. So grapefruit juice is the big one.
Yeah, I thought he said like the macrolides or a class of antibiotics that we have to know is an inducer,
Oh, that's already what it
right?
is.
Is that what rifampin is?
Rifampin is an inducer.
Inducers are the pharm, pen, grease carb.
Right, isn't rifampin a macrolide though?
No.
Oh, okay, so then the macrolides are the
Inhibitors.
Those are inhibitors, yeah.
And again, it'll be a little bit harder for you guys to memorize because you don't know what macrolides are yet, so, I mean, if you have some extra time, yeah, learn it. If not, I wouldn't like freak out about it. I think generally don't freak out about that. No. Don't freak out, you guys will be fine. Okay. Efficacy versus potency. He will also for sure ask you a question about this. So basically, what is the difference? Efficacy is how big the effect is. Potency is how much it takes to get there. So he will probably show you, or actually I can pretty much guarantee he will show you a drug table like this that will have like a bunch of different lines on it. Which is more potent? This one or this one? Things like that. So in general, the more potent is always closer to the x-axis, less drug getting to the high effect. Efficacy is strictly y-axis. So just remember those and you will be a-okay. Any questions about efficacy, potency? Cool. He also loves these graphs, and I left them unlabeled on purpose. Okay, so if this is, the line here is always my starter drug, what did I do here?
Competitive inhibitors.
Competitive antagonist. How about here?
Partial
agonist.
agonist.
Irreversible. Irreversible.
Sorry.
What would a partial do?
That's it.
Partial will pull it down slightly, but notice that here, they're starting at different potencies.
So it's for partials always more potent?
Partials are always less potent.
No, partials can be more.
But that one is,
For this,
the
yeah.
short curve is more potent than the long curve, right?
Yeah.
Yeah, I mean, I'm sorry, I meant efficacy. So, just remember, like, full agonists are always more effective.
Okay.
Right? Than your partial. And so that's the big thing to notice is on the graph, even though this might be more potent, it might have a higher affinity. It depends on
Less
what its
affinity.
affinity is for. And if its affinity is more for the inactive state, it's not going to be as effective.
Okay.
And so if you're giving this with a full agonist, you're functionally basically lowering the efficacy. Right?
But for partial agonists, they usually don't have the same exact potency as the full agonist. So if it's
Because that's
that,
the whole point is they have different affinities.
okay.
So they're not necessarily going to have the same potency.
Good.
That all makes sense? Is I'm trying to give me the glazed over look. Okay. Any other farm questions? Sweet, it's time for homeostasis, and then I will free you.